Okay, let's start again. So anyway, as I told you before, the thermal conduction is the first method of transferring heat. And the thermal conduction is the way of transfer heat through touched object, two objects that are in touch together, and especially in solids. But sometimes it happens between solid and liquid. Let's take example. When you hold a hot cup in your hand, the energy travels from the cup to your hand by conduction. So conduction here because your hand touched the cup. Also, the water inside the cup. The heat travels from the water, hot water, to the cup by conduction. But if we look to the water itself, how the water gets hot all over its parts. I heat the water from down, from the bottom, by a flame. The water go as layer, hot layer go up, cold layer go down. So it go up and down as layers. This what we call convection, and this is a second type of transferring heat. This method of transfer heat, which is convection, happened in liquids and gases. And this method happened by transferring the heat in layers, and the layer go up when it is hot and low density, and the cold layer go down. We use this idea for many things, like for example, making the air condition at the top of the ceiling or the high part of the room. Because in this case, hot air go up and cold air go down, so the air condition will always cool down the hot air at the top and make it go down, so you always feel cold. But the heater instead is at the floor because it will heat the first layer near the floor, which is gone hot and go up, and another cold go down to heat up and go up until the whole room air go hot. So we always have cold part at the top, the cooling part at the top, the heating part at the bottom. Also in the refrigerator, freezer is always at the top because freezer is what is the source of cooling to the whole refrigerator. Freezer freeze everything inside the freezer and also push some cool air to the refrigerator down there. Why? By convection. So the convection here is a moving out, the transfer of heat through gas and liquid. The difference between conduction and convection again. Conduction, touching between two objects, especially solid. Convection, travel of heat through liquid or gas. And this happened in liquid and gas by moving of layer up and down. The hot layer go up and the cold layer go down. Anybody can explain how the hot air balloon go upward in the air? Anybody know what is the idea of this? You know the hot air balloon? Hello, my class? Hello? You all mute your mic. Why? I want you to answer. How the hot air balloon go upward? Anybody have any idea about this? I can choose if you don't want to talk. Ibrahim? Ibrahim?
نعم.
Good morning.
Good morning.
Do you know the answer of this question? I'm talking about hot air balloon.
No.
Anybody know the answer?
No.
Excuse me?
No.
You don't know. Fairuz?
عشان هو تلاقي goes up يا مستر.
لا أنا مركز.
عشان الهوت اريا مستر فبيخليها تترفع.
The hot air make it go up? Why the hot air make the balloon go up?
عشان
عشانه
outlet
بيبقى
goes up.
أسخن من الجو اللي بره.
Because, as I told you, by convection, hot air go where?
Up.
Upward, yes, and cold air go down. So I always make the balloon
Upward.
yes, I make the air inside the balloon very hot always, and this make the balloon go up. If I want to make the balloon go down, I just cut off the gas or the flame, so the air inside the balloon get cool.
Cools بقى.
Yes, and the balloon go down. Thank you. I just want you to wake up. This is why I asked. Okay, so let's go
We're
for.
awake, we're awake.
Yeah, I know. Okay, just making your name participate on the screen. That's good. Okay. Number 3, radiation. So we know conduction, convection, and the third type is radiation. What is radiation? Radiation is the third type of the method of transferring heat. And this type happened in gases or space. Gases or space. This is how we feel the heat which come from the sun. Between Earth and sun, what kind of medium between Earth and sun? Gas, liquid, solid, or space?
Space.
Space, of course. There is no air between Earth and sun. Although you can feel the heat which comes from the sun. And this is due to the radiation. In this case, even if the heat travel through air in the atmosphere, it travel against the rule of convection. Convection saying the hot air go up. But in the case of radiation, the heat come downward that reach you and reach the ground. So this way, it is not moving through air by convection, it moves by radiation. Let's start to see this video. Okay, this video will explain the difference between conduction, convection, and radiation. So this is the first part, radiation from the sun. Conduction, this is conduction. Oh, read convection. Okay. Let's go back for our PowerPoint. Before going to PowerPoint, I want to make sure that you understand the difference between conduction, convection, and radiation. I will draw something and let's watch if you know what is the difference between the three cases. If I told you that This is the sun, for example. And a small fire. Now, if I put my hand in the following part, how the heat traveled through my hand. This is my hand.
مستر
Yes, yes.
هو مش المفروض اللي هي الكوندكشن دي اللي بالدايركت كونتاكت
أنا لسه
والconvection.
yes, I didn't finish drawing, and after I finish, I will explain my question.
هو
I didn't
ايه
say,
دول اصلا؟
I will tell you. Don't worry about it. Just give me 1 minute, okay? I'll draw my hand after drawing another shape. Okay. Now, if this is a cup of water, okay, if this is a cup of water and this is the sun, and this is a fire. Okay, if my hand in the following place, what kind of heat transfer, or which method the heat transferred to my hand? The first place will be, just a minute. Okay, now let's say if my hand in the position number 1 and my hand in the position number 2, I will explain everything. Or my hand in position number 3. Okay, let's remove this.
radiation صح؟
Just a minute, I will explain my question. Just a minute. We don't need the sun here. Number 1, my hand in front of the fire. Number 2, my hand touching the cup of water. Number 3, my hand at the top here in the air. In which case conduction, which case convection, which case radiation happened? Okay? Just tell me number 1 is so, and 2 and 3.
Number 1 convection.
Number 1
Convection.
convection. Okay, the heat traveled by convection.
Gas.
You talk about gas. Okay, number 2
conduction.
conduction يا مستر.
What about number 3?
Radiation.
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 It's
Okay.
radiation.
Okay, let's check my answer. My answer is number 1 by radiation.
زي ما أنا قلت.
Why radiation? I will tell you why. Because in this case,
بيطلع radiation من الفاير.
your hand is not above the fire. As I told you, convection happens when the air go up, hot air go up. But in this case, your hand is not above the fire. It is in front of the fire. So the heat need to travel this direction, not with the convection direction. This is the only direction of convection. So if I want to say, where is convection? The convection will be at this direction.
Number 3.
Yes. So this will be convection. So number 3 will be convection.
Number 3.
Okay. Number 2, as you said all, and we are accepting this, it is conduction. This is the right one. So we have here in these 3 cases, number 1 is radiation, number 2 conduction, touching the hot cup, and number 3 convection is above the fire, the hot air go up and cold air go down. Okay, now let's move for the PowerPoint again. What is conservation of energy? Something else we will talk about now. Conservation of energy. Conservation of energy mean that energy doesn't disappear and neither created. You cannot create energy or make energy disappear. But what happened? The energy travel from one shape to another, convert from one shape to another. For example, the water at the high waterfall have potential energy. When the water go downward, it change the potential energy to kinetic energy. And when it moves the turbine of high dam, for example, it change into electrical energy. So this is what we call the energy doesn't disappear, but it changed to another form of energy. This is what we call conservation of energy. And the conservation of energy mean also that the total energy stay constant. The total energy always constant. So here, if the change of internal energy are taken into account along with change in the mechanical energy, the total energy is universally conserved property. Conserved mean doesn't added, no added and no disappear. Okay, in other words, the sum of the change in potential kinetic and internal energy is equal to 0. By the way, we have to know that we have something called internal energy, or what we call mechanical energy, or the total energy of the body, and it's equal both potential and kinetic. Potential and kinetic together make the internal energy. Okay, the total of the energy is supposed to be 0. Here, this is PE mean potential energy, this is KE mean kinetic energy, and this is the change in the internal energy. The total of the 3 together equal 0. Okay, let's see this video. This device in the video, which we'll explain now, called calorimeter. Calorimeter is a device that helps to control the energy and calculate the lost and gained energy. Let's watch the video. By James Joule. Okay, here as you see, Joule, the scientist, made this device to show that first, by this arm, he will rotate it to raise the two lift up. Then after that, when we have water here and two objects work as a fan. And with a thermometer to measure the temperature of the water. When he leaves this arm, the two weights go down. And when they go down, they make this rotate and rotate in the water, which increase the kinetic energy of the water and the thermal energy. He measured the potential energy of the two weights by equation, which is mgh, we will explain it later. Then he measured the kinetic energy of this moving part by half mv squared, the speed times the mass of the object, and he measured the temperature. He found that the total of the three must equal 0. This means there is no escaping energy. This object is isolated, keep the heat inside it, no heat can escape. Okay, now let's go back. This is Joule apparatus, which we explained, and this apparatus explains the conservation of energy. Okay. Here, a simple problem. He gives you the mass equal 11.5 kilogram, the height, which the weight will move downwards. So the first one is the mass of the weight in the Joule experiment. And the h is the height, which the weight will move downwards, 1.3 meter. And g is the gravity acceleration with 9.h, it's a constant 9.81 meter per second square. We don't know U, the internal energy. This will be the equation we will use. Potential energy plus kinetic energy plus internal energy equals 0. We want the d delta U, which is the internal energy. So I will leave it here and change these two at the other side. This is the word change of potential energy mean potential energy at the final minus the potential energy at the initial, or the final minus initial. Also kinetic energy final minus initial. The word final and the initial mean if I measured, for example, two temperature at the beginning, temperature at the end of the experiment. At the beginning, call initial temperature. At the end of the experiment, called the final temperature. And the difference between them is subtraction between final minus initial. Okay, he let the delta U here and move everything to the other side. We have BE plus BEI, sorry, final plus initial minus final plus initial. Okay. Of course, here this happened due to the change in the signal. You get the negative plus positive, negative plus positive. Okay, don't forget that the change in any quantity indicated by delta. Delta, this means the change. Change means it was 3 turned to be 7. The difference, 4. This called the change in temperature. Because the mass began at rest, kinetic energy equals 0. Kinetic energy is the energy of motion. So if the object starts the motion from rest, the two weights were at the high place at rest doesn't move. So the kinetic energy initial is 0. If we assume that kinetic energy final is small compared to the loss of potential energy, when the object moves downward, the potential energy change into kinetic energy. But some of this potential energy lost by air friction, by anything. So the final kinetic energy is not always equal the potential energy change. So because of that, kinetic energy is less than potential energy. So here we can say that KEF, the kinetic energy at final, is 0 and potential is and finally like 0. Okay, because all of the potential energy is assumed to be converted. All the potential energy, mgh, the potential energy measured by the equation mgh, m is mass, g gravity acceleration, h is height. The potential energy change completely into kinetic energy. Okay, can be set equal to mgh if PE is set equal to 0. So PE is mgh and PF is 0 because at the end of the experiment, the object will stop at lower high. The lower high equals 0. So the mgh for final equals 0. Now let's go back for delta U, the internal energy, which equal negative PEF, as I told you at the previous page. Here, this is 0, mgh, 0 and 0, so the total internal energy will equal mgh. Now let's go for calculation. M is the mass, I gave it to you at the beginning, 11.5. G, the gravity acceleration, 9.8. And this is the distance it will move horizontally, vertically, 1.3 meter h. The result will be 1.5 times 10 power 2 joule. This is the total internal energy of the device. Okay, this is the end of section 2, and I hope it is useful. And we will have a summary, a section review for section 1 and 2 now. Okay, this is section 3, which we will start with today, but I want you to see the section review for section 2 and section 1. Okay. This is the answer of section review 2. Okay, I want to take a screenshot for this. And anyway, I will put the video on the internet so you can take this again. And before that, this is the answer from my book. And before that, you have the questions of the section review. Using microscopic interpretation of the temperature and heat to explain how you can blow on your hand to warm them and also blow on a bowl of hot soup to cool them. So you can use the same process once to heat and once to cool down. And this is because in the first stage, of course, your hand is cooler than your internal air. So the heat transfer from your hot air, which come from your mouth to your hand to warm it up. But in the other case, the soup is very hot than the air which come from your mouth. So heat travels from the cup to the air you will blow from your mouth. This is how the two processes happen, and you will find every answer for this question at the book. Okay. We have less than 1 minute now to finish our session. Do you have any question for today? Hello, my dear.
لا تمام مستر تمام.
This is your
Thank you.
picture